Hello, friends. Let us begin the limits and continuity in higher dimension, like for functions of two or three variables. See, in 12th standard, you studied the function of one independent variable, like y equal to fx, and you have like, suppose say you have like y equal to say x square. So this is a function of one independent variable x. So if you have any function like having one variable, then it represents a curve. Any function of one variable represent a curve. Same way, if you have a function of two variable, two independent variable like z equal to fxy, then it represent a surface. It represent a surface. Like you have, this is a function, and this is a function of two variable. Like this function is of z equal to x square plus y square. So this is a surface z equal to x square plus y square. Now, in function of one variable, in your 12th standard, you studied limit, continuity, then differentiation, then integration, and so on, and their applications. Same way, here also for function of more than one variable, we studied the limit, continuity, differentiation, integration, and vector calculus also of the for the function of more than one variable. So for a function of one variable, you have the limit like this, limit x tends to a, fx equal to say suppose L. Then you know that its definition is like for a given epsilon greater than 0, there exists some delta greater than 0 such that modulus of fx minus L less than epsilon whenever modulus of x minus L less than delta. So basically, in function of one variable, you have like a here, and modulus x minus a less than delta means your x lies in the interval a minus delta, a plus delta, and x lies in this region. So it may be you say that x tends to a from this side or this side, or you say it is left limit or a right limit. And if that both limit exist and equal, then you say that the limit exists, this one. Now the similar concept we used for the function of two variable, like limit xy tends to ab, fxy equal to L. So if we use the same definition, then it will be like this, that for a given epsilon greater than 0, there exists delta greater than 0, so that modulus of fxy minus L less than epsilon whenever 0 less than modulus of xy minus ab less than delta. So basically, this represents a distance between x and a. So same way, this represents a distance between xy and AB. And we know that formula for distance formula. So it is like modulus of xy minus AB. The distance is between xy and AB is x minus a square plus y minus b square and its root less than delta. So basically, this represent what? So this is nothing but x minus a square plus y minus b square less than delta square. So here we have the interval, while here what do we have? We have a circle. Here we have a circle and whose center is AB and the radius is delta. Here we have a circle whose center is AB and radius is delta, and all the points lying inside this circle. So here xy tends to AB from many directions, infinitely many ways. So in function of one variable, we have the limit only two kinds, like left hand and right hand limit. Here we have infinitely many paths, infinitely many paths. And if the limit is same on all these infinitely many paths, then we can say that this limit exists. So to find the limit in function of two variable is little bit difficult. But then if we have limit not equal on two different paths, then we can say that the limit does not exist. So this is the simple concept of limit. So here let us solve some simple example, like